This is mathheals.com if you're wanting more links to YouTube videos on math. Let's take a look at business and economics applications. Now this first problem says find a number of units X that produce a maximum revenue R. So we're given revenue function. R is equal to 1500 x squared minus x to the third. Excuse me. So to find the maximum revenue, actually this wants us to find the number of units X that produce the maximum revenue. We don't have to actually find R. We may just for fun, but you have to find derivative. So we'll go ahead and find our first derivative. Derivative of R with respect to X. Remember, you take your power, put it up in front. So you got 1500 times 2, and then you lower your power by 1. Minus, take your power, put it out in front, lower it by 1. So that gives us 3000x minus 3x squared. Then we set that equal to 0. And we want to solve this. Now I can factor out a GCF. They both have a 3 and an x in common. And that gives me 1000 minus x equal to 0. And I'll set 3x equal to 0, and I'll set 1000 minus x equal to 0. Excuse me. I want to solve each one of these for x. So here, this one I'll divide both sides by 3. And you get x is equal to 0. This one, take negative x to the right side. And we get x is equal to 1000. Now the 0 doesn't make any sense, that your maximum revenue will be 0. Well, if you're creating 0 units, you won't have any revenue. I suppose that could be the highest you might have. It might be all the rest might be negative, but we assume that's false. We'll know if the other one's true in here in just a second. Now we're going to build a table of intervals based upon this. Here's x equals 1000, here's infinity, and here is negative infinity. Though negative infinity doesn't make any sense. Actually, let me go ahead and put a value there that does make sense. Can't make negative units. Let me just put 0 here. Okay. Now I want to pick test cases. X equals 1 would be a good one. Some value between 0 and 1000. And over here I'll pick, I don't know, 10,000 maybe? 2,000 might work. Yeah, 2,000 would be better, I think. And we want to plug this into our first derivative. So plug into your derivative, which is right here. So I got 3000 times 1 minus 3 times 1 squared. Now we really don't care what this value is, because we care what the sign is. Excuse me. 1 squared is 1, times 3 is 3, and 1 times 3000 is 3000. So we got 3000 minus 3, which is positive, which means this is increasing. If I put 2000 in, so I got 3000 times 2000 minus 3 times 2000 squared. Was that 6 with 6 zeros? 6 million minus, and this would be 6, 12. 12 with 6 zeros. So that's 12 million. 6 million minus 12 million is negative, so this is decreasing. So since this is increasing and this changes to decreasing, this is indeed a max. So max at 1,000 units. Now, if we want to know what the R would be, we just take our R and we plug in 1,000 for the X. And let's see what that gives us. Okay, so we got 1,500. And beginning parentheses 1,000 squared minus 1,000 to the third. What is that? 500 million. If my eyes aren't getting off. So revenue would be 500 million. They were just asking for X in that problem, but I thought I'd show all. Excuse me. Well, let's take a look at second problem. It says find the number of units X that produces the minimum average cost per unit. So we're given a cost function. What if I probably got enough room. Yeah, I got enough room. So C is equal to 0.01 x to the third plus 2x plus 16. Well, they want us to minimize the average cost per unit. And the average cost of unit, I put the formula down here. C bar is equal to your cost divided by X. So to find C bar, we're going to take this, divide by X. So 0.001 x to the third over X plus 2x over X plus 16 over X. If you got multiple terms, then you can put each one of them over the X. Which gives us 0.001 x squared plus 2. And I won't put this in a form where I can take the derivative. So I'm going to rewrite this as 16x to the negative 1. It's x the first part down here, and I take it up on top, becomes x to the negative 1. Now, they want us to minimize the average cost per unit. So we want to take the derivative of this. Derivative of C bar with respect to X. Take my power, put it out in front. So this would be 0.002x. 2 times 0.001. 2 drops away. Take this, put my power out in front. Negative 1 times 16 is negative 16, and lower by 1. Now this would be 0.002x over 1 minus 16, and I'll take the negative exponent down below, so it becomes x to the positive 2. Now we want to get a common denominator, which would be x squared, so I'll multiply the first fraction, top and bottom, by x squared. So I get 0.002 x squared times x is x to the third, and x squared times 1 is x squared minus 16 over x squared, which gives us 0.002 x to the third minus 16 over x squared. Find our critical values. We set whenever we have a fraction, we set top part equal to 0 and the bottom part equal to 0. So we got 0.002 x to the third minus 16 equals 0, and x squared is equal to 0. Well, the x squared equals 0 would give us x equals 0. And we've already indicated that doesn't make a whole lot of sense because your cost, if you haven't produced anything, your cost is going to be, if you just haven't even started business, then probably your cost is 0. This is like before you even start. Now here I'm going to solve for x. So I'm going to take the sorry for the coughing. Still sick. Take negative 16 to the right side, becomes a positive 16. I'll divide both sides by 0.002. And we get x to the third is equal to, and I'm not very good with decimals, so I know it's 8 something, or not 8, 880, 800, 8,000, something like that. Let's see. Watch me be completely wrong. 16 divided by 0.002. 8,000. Now we're still trying to find our critical value. X to the third is x to the 3 over 1 power equals 8,000. And if you have x to a power, you can raise both sides to the reciprocal of that power. So we can take both sides of the 1/3 power. So here these x's cancel, the 1's cancel, we got x. 1/3 power is the cube root. So we've got a cube root of 8,000. Cube root means we're looking for something times itself 3 times. Well, 20 times 20 times 20 will give us 8,000. And we've got a set of 3 of something, so that 20 is going to come out in front. And we got x is equal to 20. Now we know from college algebra that if we have a polynomial and we have x to the third, it means we have 3 answers. It appears like we are ignoring 2 of them. We are. If you have x to the third or x to any power, you can solve it this old style way that you may have learned back in high school, because the other 2 answers are going to be imaginary. Okay, so that's our critical value. Now it's asking us find a number of units produces a minimum. That's probably our answer. We just need to make sure that it's actually a minimum. So let's build our table of intervals. Here's 20. Here's infinity, and I'll put 0 here since again negative infinity doesn't make any sense. Pick test cases. 1 would be a good one, and 100 probably would be. That's easy to take it to a power. And there's our derivative. We'll plug it into our derivative. So we've got 0.002 x to the third minus 16 over x squared. Well, the x squared, whenever you square something, it's always positive, so I don't need to worry about plugging into the bottom part. I just worry about the top part. Because all we're caring about is a sign. So we're plugging it into our derivative. So I got 0.002 times 1 to the third minus 16. 1 to the third is 1 times 0.002 is 0.002 minus 16. I don't know what it is, but it's negative. Negative divided by positive is negative, so this is decreasing. Well, let's plug 100 in. 0.002 times 100 to the third minus 16 over a positive number. Just because I don't want to think about decimals that much this morning. 0.002 times 100 to the third minus 16. And we got a positive number. So this is increasing. So it changes from decreasing to increasing. So this is indeed a min, which is what they were telling us. They wanted us to minimize it. So the minimum occurs at x is equal to 20. And let me save this, business and economics applications. We'll start a new page. Okay, let's look at our next problem. It says find a price that will maximize profit for the demand and cost functions, where P is the price, X is the number of units, and C is the cost. So they give us our demand function. Little p is equal to 80 minus x. And they give us a cost function, which is 200 plus 40x. Find price to maximize profit. So our goal is to maximize the profit. Excuse me. I guess that's all information they give us. Now our profit is equal to revenue minus costs. And revenue is equal to x times our demand function, little p, versus the uppercase P. Excuse me. Well, so over here, our profit is going to equal to our revenue minus our cost, which is little x times little p minus c, which is x times 80 minus x minus our cost, 200 plus 40x. Well, x times 80 is 80x. X times negative x is negative x squared. Remember, if you have a negative out in front of parentheses, flips the sign of everything on the inside, so that becomes negative 200 minus 40x, which gives us negative x squared. 80x minus 40x is 40x. And then I'll carry down the minus 200. Now we want to take the derivative of the profit with respect to x. Take your power, put it out in front, lower it by 1, so that becomes negative 2x plus 40. I'll set that equal to 0. And solve for x, so I'll take negative 2x to the right side, and it becomes a positive 2x. Divide both sides by 2. 20 divided by 2 is 20. Or 40 divided by 2 is 20, sorry. And that's probably the value we're looking for. Let's build our table of intervals. And I'll put 0 over here. And I'll put infinity over here. Can't have negative units again. So we'll pick test cases. X equals 1 would be a good one. And x equals probably 30. And I want to plug them into our derivative. Which shows negative 2x plus 40. Well, negative 2 times 1 plus 40 is positive, so it's increasing. Again, we don't care what the value is, we just care about the sign. And this is negative 2 times 30 plus 40, which is negative, so it's decreasing. So it changes from increasing to decreasing, so it is indeed a maximum. So we've got our maximum at x is equal to 20. Now what they're asking us for is find a price. And p is the price, little p. So we're going to plug that into our demand function. So little p is 80 minus x. So 80 minus 20 would give us $60. That would be the price that will maximize profit for the demand and cost functions. And I don't got room for another one there, looks like. So let me save that. Let's look at our next problem. Let's find the point of diminishing returns given a profit function. The point of diminishing returns is where the concavity changes. The point of diminishing returns is the same as the point of inflection. So we need to find our second derivative. So I got p is equal to 1/6 x to the third minus 5x squared plus 2x plus 20. Okay, so for our first derivative, take your power, put it out in front, lower it by 1. Take your power, put it out in front, lower it by 1, and then plus 2. That gives us 1/2 x squared minus 10x plus 2. Then for our second derivative, take your power, put it out in front, lower it by 1. Then minus 10x becomes minus 10, which gives us x minus 10. Well, we need to find our critical value, so we'll set that equal to 0 and solve it, which gives us x equals 10. And assuming this exists and the concavity changes, this would be our x part of our point of diminishing returns. So let's put it into a interval. Over here is infinity. This I'll put 0 in. And we'll pick test cases. X equals 1 would be a good one. Some value between 10 and infinity. Like 11 might be good. Yeah, 11's fine. And we want to plug these into our second derivative. So plug these into p double prime. Okay, which is x minus 10. So I put 1 in for there. I get 1 minus 10 is negative. So this is concave down. If I put 11 in here, I get 11 minus 10, which is positive, so it's concave up. Well, the concavity changes, doesn't it? Which means that is our POI, which is aka our point of diminishing returns. So we're going to take the x value and plug it into our original function and find out what our profit's going to be. So now, plug x equals 10 into p. Okay, so we got p is equal to 1/6 times 10 to the third minus 5 times 10 squared plus 2 times 10 plus 20. And I don't want to think too hard this morning, so let me go use a calculator for this. Okay, so 1/6, then 10 to the third, minus 5, 10 squared, plus 2 times 10 plus 20. So we got negative 293.33. Now let me double check my my work here. So we got 1/2 x squared minus 10x plus 2 x minus 10. Set that equal to that. Okay, plug 10 into there. So 1/6 times 10 to the third minus 5 times 10 squared plus 2 times 10 plus 20. Okay. So our point of diminishing returns is going to be 10 comma negative 293.33. I rounded that because of dollars. Now we got a negative profit, didn't we, when we did that? Realize I make these numbers up, so they don't always come up nice. But my main goal here is to show you the steps, not to put valid data in there. Okay, let's look at number 5. I think I have room. It says when a product costs $20 per unit, sales are 400 units per week. After a $10 increase, sales fell to 350 units per week. If the demand function is linear, what price per unit will yield a maximum total revenue? Okay. And a hint, revenue is equal to little x times P. P is our demand function, price. Okay, so they give us, when a product costs $20, sales are 400. We can put that in point form, $20, sales are 400. After a $10 increase, that means it went from 20 to 30, sales fell to 350 per week. So we're given that. We can use that, because they tell us the demand function is linear. We can use that to find the equation for little p. Well, first thing we have to do is find the slope. Slope is a change in y over change in x. And if I were to put letters here, this would be x1, y1, x2, y2. And our formula is y2 minus y1 over x2 minus x1. So I'll have 350 minus 400 over 30 minus 20. After $10 increase. Okay. So 350 minus 400 gives me a negative 50. 30 minus 20 gives us negative or 10, which then gives us negative 5. Okay, so then we want to take that, and we want to plug one of your points into this equation, y is equal to mx plus b, and plug in the m we just found and solve for b. Now I'm going to pick my first point here. I'll plug the 20 in for the x and the 400 in for the y. So we've got 400 equals, negative 5 is our m, and x is 20, and then plus b. So we got 400 is equal to negative 100 plus b. Take negative 100 over, it becomes a positive 100. And we get 500. So we got y is equal to mx plus b, like that. Now this is just using those 2 points. And we said that this represents our demand function. So this is little p is equal to negative 5x plus 500. So it's asking us about revenue. actually. Let me draw that arrow. Revenue is x times p. So we got little x times p, which is negative 5x plus 500. So revenue is equal to negative 5x squared, multiplying the x through, plus 500x. Okay, what they want us to do is what price per unit will yield a maximum total revenue. So we're trying to maximize the revenue. So we need to take the derivative of r. So we take the derivative of r with respect to x, r prime. That gives us negative, take your power, put it out in front. Negative 5 times 2 is negative 10x. And 500x becomes just 500. Well, set those equal to 0. So I got negative 10x plus 500 equals 0. And solve for x. So I take negative 10x to the right side, becomes a positive 10x. Divide both sides by 10. And you get x is equal to 50. Well, let's build our table of intervals. Here's infinity, here's 0. We'll build our test cases. We want to check to make sure this is actually a maximum. So I'll plug in x equals 1, and I'll plug in x equals, where's our derivative at? Right here. I could probably put in 60 to be fine. And then plug into our derivative, which was negative 10x plus 500. Now again, we could care less what the value is, just care about the sign. So negative 10 times 1 plus 500. Negative 10 times 1 is negative 10, plus 500 is positive, so this is increasing. Here I got negative 10 times 60 plus 500. Negative 10 times 60 is negative 600, plus 500 is negative, so this is decreasing. So it changes from increasing to decreasing, so it is indeed a maximum. Now they're not asking us the number of units that could give us a maximum. They're asking us what the price is going to be. So we have to go back up here to our little p. So little p is equal to negative 5x plus 500. And we'll plug in 50 for the x. So we got negative 5 times 50 plus 500. So our price was that negative 250 plus 500. Well, that would give us, price should be 250. Let me save that. Anytime you got a word problem and they're telling you something follows a linear, they're kind of telling you to do what we just did there, unless they already gave it to you in that form. Okay, so let's look at this one. Medical science. I found this one on the internet. I was doing some Googling trying to find something to be medically related. Velocity there during cough is modeled by this formula. V is equal to K times capital R minus little r times little r squared. Okay, and little r is between 1/2 capital R and R. Now some books will put 0 here, and then other books I've found would explain why they use 1/2 R. If you go below 1/2 capital R, that means you're suffocating. You're breathing. You're not going to die. 0 doesn't make any sense because capital R refers to our normal radius of the trachea. So if it's 0, that means it's completely closed off, and there's no velocity then. So I can see why the 0 didn't make any sense. And k is a constant. That probably varies depending upon the person. R is your... I couldn't find anything more beyond that for k. Capital R is your normal radius of the trachea, and little r is the radius of the trachea during a cough. And this is the formula to give you the velocity of the air. It says find the r that will maximize the velocity. Okay, so we want to maximize the velocity. And it says find the r that will maximize it. Now, capital R is our normal radius. That doesn't change. But this does, the little r. So we're going to take the derivative of our velocity with respect to little r. Well, this one I could multiply these all out. This is equal to kr minus k little r times r squared, which would give us, take r squared times this, that gives us kr little r squared minus kr to the third power. Okay, so take the derivative of that, take your power, put it out in front, so we got 2k capital R, then lower your power by 1, so it becomes r to the first, minus, take your power, put it out in front, so we got 3k r squared. Let me double check that. 2k r, okay, minus 3k r squared. Now we want to set that equal to 0. That's how we always do the maximum. So 2k capital R little r minus 3k little r squared equal to 0. And you notice how they all have a k? I can divide everything by k to get rid of that. Because it's a constant, but it's not 0. And that gives us 2 capital R little r minus 3r squared equal to 0. Now here we can factor out a little r, because they have that in common. And that gives us, let's see, 2 capital R minus 3 little r equal to 0. Now, zero factor property from college algebra. It says if you got 0 on one side and you factor the other side, you can set each factor equal to 0. Now set r is equal to 0, and 2 capital R minus 3r is equal to 0. Well, little r is equal to 0. Little r, I guess I wrote it over here, is a radius of a trachea during a cough. Well, that doesn't make any sense for that being our maximum velocity, does it? So I can ignore that one. There's no velocity at all. If a little r radius of the trachea during a cough is 0, there's nothing coming out. Okay, so I'm going to solve this for little r. So I got 2 capital R is equal to 3 little r. Take that over to the right side. Then divide both sides by 3. So we got 2/3 r is equal to little r. Okay, so let's verify this is a maximum. So I got r is equal to 2/3 capital R. And over here I'll put 0, and over here infinity. We know your infinity doesn't make any sense, but we, barring putting any kind of other reasonable number, we just put that on there. And we'll plug in our pick test cases. Now 2/3 times r, that's 2/3 of r, which means I could over here pick r, because 2/3 times r and 1r, 1r is greater, isn't it? Over here I could pick 1/3 r. I don't know much about it, but 1/3 r is less than 2/3 r. And then we'll plug them into our derivative. 2k r squared. Now we said the k doesn't matter because we can divide it out. If it was a it doesn't say it's a positive constant. Negative. If it was negative, that wouldn't make any sense. So it should be a positive constant. Okay. So then we have 2 RR. So let me write that down. So we're plugging in the 2r little r minus 3r squared. Same here. That seems weird because we don't have numbers to work with, but so for little r, we're going to plug in 1/3 r. So we got 2 capital R times 1/3 capital R minus 3 times 1/3 r squared. Okay, so that gives us 2/3 r squared and minus 1/3 is 1/9 because we're squaring it. So that's 1/9 times 3. That gives us 3/9 or 1/3 r squared. 2/3 r squared minus 1/3 r squared. I don't know what it is, but it's positive, so this is increasing. Now if I plug it in here, I got 2r, and we're plugging in capital R for little r. So we've got 2 capital R times r minus 3 times capital R squared. That gives us 2r squared minus 3r squared, which these are like terms. 2 minus 3 is negative 1. R squared, don't know what it is, but it's negative. So it is indeed a maximum. So maximum occurs at little r is equal to 2/3 capital R. Now little r is the radius of trachea during a cough, and this is a normal. So the maximum occurs when it's 2/3 of the normal. So, which would imply that it becomes smaller during a cough. So, anyway. Now again, the k doesn't matter. The only way the k might matter is if it was negative, but then that doesn't make any sense for your velocity. So let me save that. And let's look at our next problem. Another medical science. Let me grab a drink real quick. Excuse me. And just getting ready for the next problem. Book does a really good job explaining this. Next topic, not this one, but the next one. So I just wanted to get to the correct page. Okay, the concentration C of T in milligrams per cc, cubic centimeters, of a certain drug is given by this formula. Now these are made-up numbers. The reason why is the concentration of a certain drug, and this is in your bloodstream, for example. It varies depending upon which medicine you're talking about. Some stay in your system a long time, some stay less. So every drug will have different numbers here. But this seemed to be kind of a constant formula that I'd found, is that they just have different numbers here. Of course, it tie to whichever drug you're looking at. And T equals the number of hours after the drug was taken. Now it says how many hours after the drug was taken will the concentration be at a maximum. So we want to maximize the concentration, which is C of T. So maximize C of T. Okay, this is the quotient rule. This will be P and this will be Q. We need P prime. The derivative of 0.02t is 0.02. And for Q prime, this is the chain rule. We got parentheses to a power. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside the parentheses. So we got 2 times t plus 3. And derivative of t plus 3 is 1. So that drops away. Okay, so now we're ready to plug in our formula. P prime Q minus P Q prime over Q squared for our quotient rule. Okay, so C prime is going to equal to P prime, which is 0.02, times Q, which was T plus 3 squared, minus P, which is 0.02T, times Q prime, which is 2 times T plus 3 over Q squared. So we got T plus 3 squared. Let me double check that. P prime times Q minus P times Q prime. Okay. Now up on top, they both have a 0.02, so I can factor that out. And this one has T plus 3 to the second power, so 2 of them. And this has T plus 3, so 1 of them. So we can factor out 1 T plus 3. And let's see what's left. That's gone. One of these is gone, so we got T plus 3 minus that 0.02 is gone. This T plus 3 is gone. And so we got 2 times T, which gives us 2T. Over T plus 3 to the 4th power. When you're raising one exponent to another exponent, you multiply them together. Let me double check this. Okay, T plus 3 is gone. 0.02 is gone. 2T. Okay. Now this T plus 3 here is going to cancel with one of these T plus 3's down here. So this is 0.02 times 2T minus, or T minus 2T is negative T plus 3 over T plus 3 to the 4th power. Try it again. 3rd power. That didn't look right when I wrote it down. Okay, so that's about as good as we're going to get. So we're going to set the top part equal to 0 and the bottom part equal to 0 to find our critical values. So I got 0.02 times negative T plus 3 equal to 0. And over here we're going to have T plus 3 to the 3rd power is equal to 0. Now, again, if you have parentheses and then you have a number out in front of it equal to 0, you can drop the number out in front. So we got negative T plus 3 equals 0. Take T to the right side, and we got T is equal to 3. On this one, if you got parentheses to a power equal to 0, you can just set what's inside the parentheses to the power. So T plus 3 is equal to 0, so T is equal to negative 3. Now we're talking about time. Negative 3 doesn't make any sense. That's before you took the drug. So our only possibility is that T is equal to 3. Okay. Well, the instructions were to how many hours after the drug was taken will the concentration be at a maximum. So we just need to verify this is actually at maximum. So plug that into our intervals. We know a drug can't stay in your body infinity, but we pretend that's true. And of course our smallest one that makes any sense is 0. Okay, so we want to pick test cases. I'll pick T is equal to 1 and T is equal to 5. And we want to plug them into our derivative, which is this right here. So plug into our derivative. So we're going to have 0.02 negative t plus 3 over t plus 3 to the third power. Okay, so if I plug 1 in, got 0.02 times negative 1 plus 3 over 1 plus 3 to the third power. Negative 1 plus 3 is 2, which is positive, times 0.02, which is positive. Positive times positive is positive. Divided by positive, this is increasing. Now if I plug 5 in, 0.02 negative 5 plus 3 over 5 plus 3 to the third. 5 plus 3 is 8, that's positive. And third power is positive. 0.02 is positive. Negative 5 plus 3 is negative. Negative times positive is negative. Divided by positive is negative. So this is decreasing. So it is indeed, it's increasing and then changes decreasing. This is indeed a maximum. So our maximum concentration occurs at t is equal to 3 hours. Let me save that. This is interesting. I found one book that specifically had in their title that they're a calculus for the medical sciences, along with biology. And I'm sitting there reading through the book, and I can find hardly any medical examples. And I'm sitting there, why are you claiming this in your title? You're not even close to meeting what I would define as medical. Okay. Now our 8th problem talks about elasticity. And here's where I go to the book, because they do a pretty good job explaining it. This is a response to your price change. You know, this is the way I think of it. Some items, it doesn't matter if you change the price, because people pay it no matter what. Water. What are you going to do? Not drink water and die? You don't have any choice. For me, gas is that way. Doesn't matter what they charge, I have to buy it, period. It's either that or I quit my job and just sit at home and play Call of Duty all day. Now, some people, the price of gas changes what they do. Maybe they don't take trips on weekends. I don't go anywhere, so it doesn't affect me. But that's what it's talking about, is as they change the price on something, how does it affect the demand? Let's see. It talks about here, a drop in the price of vegetables might result in much greater demand for vegetables. Such a demand is called elastic. On the other hand, the demand for items such as milk and water is unresponsive to changes in price. You know, if they drop the price of milk, you're not going to go out there and probably eat a bunch more or drink a bunch more milk. That's inelastic. Okay. Now let's see how to work these. So we'll talk about what those are. Okay, so we got P is equal to 800 minus 2x. And I didn't mean to make that a big P. Let me go erase that. There we go. Boy, my eyes are. Where did 800 come from? Quit drinking before I create these videos. Just kidding. I don't drink. 500 minus 2x. I get high on math. And x equals 50. Okay. Find the price elasticity of demand for the demand function at the indicated x value. Is the demand elastic, inelastic, or of unit elasticity at the indicated x value? Identify the intervals of elasticity and inelasticity. Well, we'll kind of go about this a little bit different. Our price elasticity of demand is given by this function. So that little n looking thing, that's eta. eta is equal to p divided by x over dp dx. Okay, so first step is we want to find eta. I'm not very good at creating this, so it's not bad for me. So find eta, and that's equal to p divided by x over the derivative of p with respect to x. So p 500 minus 2x over x all over the derivative of that. Well, if I take the derivative of p with respect to x, 500 drops away, and that just gives me negative 2. So eta is going to equal to, when you got a single fraction up on top like that, you can take that denominator, the x, and put it down with this one. That only works if you got a single fraction. So this becomes 500 minus 2x over negative 2x. Now, solve absolute value of eta is equal to 1. Okay, so and what this is doing here, I should say, we're finding the intervals of elasticity, inelasticity. So this is finding the intervals of start grade 2 tomorrow and learning to write. Okay, so finding intervals of elasticity slash inelasticity. Hopefully I'm spelling that right. That's what these steps are for. Okay, so I'm going to put the 500 minus 2x over negative 2x inside the absolute value and set it equal to 1. Well, if you remember this from college algebra, if you have the absolute value of something is equal to a number, you can drop the absolute value and set it equal to positive the other side, and you drop the absolute value and you set it equal to negative the other side. And now, to solve this, I need to get rid of the fractions, so I'll multiply both sides by negative 2x. And on the left side here, the negative 2x's cancel. So we'll have 500 minus 2x equals, and equals negative 2x. And if I take negative 2x over, I get 500 is equal to negative 2x plus 2x, which gives us 500 equals 0. So we ignore that side. Oftentimes on these, you have one side that doesn't work at all. So let's do the other one. Again, I'll multiply both sides by negative 2x. And when I do that, those negative 2x's are going to cancel. And we got 500 minus 2x is equal to a positive 2x. Now we're solving for x, so I'll take negative 2x to the right side. So we've got 500 is equal to 2x plus 2x. 500 is equal to 4x. Divide both sides by 4. And I think that's 125, but let me plug that in my calculator just to make sure. Let's see. 500 divided by 4. 125. Yep. Now what this is This, if we were in, doing mins, maxes, concavity, and so forth, this is our critical value. Well, this is our critical value for elasticity. So we're going to, that was step 2, solve that. Step 3, build a table of intervals. So build a table of intervals based on this critical value. This is our critical value. Pick test cases. Plug them. And I have this on this formula right here. Plug them into the absolute value of eta. Plug them into that and simplify. Now this is given over here. If your absolute value of eta is greater than 1, it's elastic. So we're looking at sine. If the absolute value of eta, boy, my etas don't look very good, is less than 1, this is inelastic. Look over there for a good picture of eta. Okay, we came up with 125. Okay, so over here is x equals 0. X equals negative doesn't make any sense. And over here is infinity. So we want to pick our test cases. X equals 1 would be best there, and let's say x equals 200 would be over here. We want to plug these into the absolute value of eta. If I come up here, the absolute value of eta is actually right here. That's what the absolute value of eta looks like. So absolute value of 500 minus 2x. Absolute value of 500 minus 2x over negative 2x. And if I plug that in, plug the 1 in, I would get 500 minus 2 times 1. Let's say sine up here. It's based upon whether it's less than 1 or greater than 1. If I plug that in, I get 500 minus 2, 498, divided by a negative 2. That's going to be greater than 1, isn't it? So this is elastic. So this is greater than 1, which was elastic. That means that our interval of elasticity is from 0 to 125. Though 0 probably wouldn't be a valid one, but since it's usually open interval, then that's fine. Okay, so if I plug in 200 here, I get 500 minus 2 times 200 over negative 2 times 200. Well, that gives us 2 times 200 is 400, so 500 minus 400 is 100 over negative 400. Those zeros would cancel, and the absolute value of negative 1/4 gives you a positive 1/4, which is less than 1. Less than 1 means this is where it's inelastic. So it's inelastic from 125 on, within limits. You know, obviously infinity doesn't make any sense. Okay, so that's our intervals of elasticity and inelasticity. And actually, let me write them down. So it's elastic from 0 to 125. And I didn't get any maximum here, so we'll just say infinity. Inelastic, when it's 125 to infinity. And then the first thing they're asking, find the price elasticity of demand for the demand function at the indicated x value. So I got this x value here. I can plug that into my formula to see what I get. Of unit electricity. Okay. So now plug in x equals 50. Now we know what it is, because that 50 is between 0 and 125, so this is elastic. But let's see what the value is. So I got absolute value of 500 minus 2x over negative 2x. So I got 500 minus 2 times 50 over negative 2 times 50. 2 times 50 is 100. 500 minus 100 is 400. And this gives us negative 100, which would give us negative 4, which would give us 4. Which we've already indicated is elastic. And these are our intervals of elasticity and inelasticity. And I guess that's all they're asking for in that problem. So let me save that page. And we're done with that section. Let's stop my recorders. I should change that to business and economics. Business, economics, and medical applications. And medicine applications? Medicine applications. There we go. Okay, then F9.